Jai Hind, everyone. Before I begin, I would like to think about this. In this time, it takes me to finish the sentence. A child somewhere in the world just died from the water-borne disease. Every 8 seconds. I repeat, every 8 seconds. That's 10,000 children every single day, and 80% of these deaths happen in developing countries like India, where rivers are the lifeline of 5 million peoples. We, the team Steve, and we built environmental Sentinel prototype, a AI-powered system that doesn't just detect pollution; it predicts it before community even knows about it. Let me show you how. Next slide. Let me paint you a picture of the crisis. 70% of the Indian surface water is polluted. That's not a typo. I repeat, that's not a typo. It's actually 70%. 3.5 million people die every year from the water related disease. That's more than COVID killed in worst year. Every year, and the economic cost 4.5 lakh crores rupees annually. It's nearly 2% of Indian GDP just on treating waterborne disease. I repeat, 4.7 lakh crore rupees annually just to treat waterborne diseases. Now, here's the tragedy. We have monitoring system. The government spend crores on them, but they fail. Why? Manual spamming don't done once a month. Maybe a factory can dump waste 29 days without anyone knowing. Lab result takes 7 to 4 days. By then, pollution has traveled 50 kilometers downstream or more than it. Thousands have already consumed it, maybe in self of drinking water or any other purposes. And the equipment which is cost 10 lakh per monitoring system. I repeat 10 lakh. So we have just 100 station monitoring 20,000 kilometers of the rivers. The math doesn't work here. The system is broken. But we could fix it. Next slide. Next slide. So this is environment sentinels. It's just not a monitoring system. It's a complete shift. We develop a low-cost sensor node along rivers. This node measures pH dissolved oxygen and conductivity, air quality, and all critical pollution indicators. They communicate via LoRa. LoRa stands for long range radio, which can transmit data 5 kilometers without any cellular network. I repeat, 5 kilometers without any cellular network. No SIM card, no monthly cost. The data flow to our Google Cloud backend where TensorFlow AI and analyze patterns in the real time. And here's the magic. We don't just tell you when pollution happens, we tell you before it happened. I repeat, we tell you before it happened. Real time 30-second update instead of waiting 14 days for lab result. Predicate, Predicative, our AI learned patterns. It can predict pollution events 13 minutes before they spread to polluted areas. That's 13 minutes to close water intake, warm communities, dispatch responses. Affordable, each node cost 17,000. The cheapest commercial alternative is for rupees 10 lakh. We are not 10% cheaper, we are 90% cheaper. This means instead of one expensive station, we can deploy 50 of our sensors for the same cost. That's an incremental improvement. That's transformation. Next slide. Now, you might ask, are there other solutions also? So, yes, there are other solutions, but why do we succeed? Let me show you the competitive landscape. Traditional government system, 14 days lab delays, cost 10 lakh per station, no prediction capability, they are outdated. IoT startup exists. There are many, maybe 5 to 10 in India. They are better updating every hour, costing 2 to 5 lakh, but they have critical flaws. They need 4G connectivity, so they can't work in the remote rivers areas where there is no network. And that's exactly where illegal dumping happens. They have no predictive AI and they tell you what happened, not what about to happen. They are proprietary locked system, expensive maintenance, vendor dependency. Environment Sentinel is different. 30-second update predictive AI that warns before pollution spread. 17,000 per node. That's 90% cheaper than any commercial alternative. We use LoRa networking, 5 km range without any cellular data, deploy us anywhere. And we are 100% open source. Government can modify, extend, or do alternative changes, own it forever. The global market is 2.8 billion. India alone has 150,000 plus potential development cities or sites. And we directly address UNSDG 6 clean water, which is a core global priority. This isn't a school project, this is a scalable solution for real world crisis. This is an industrial level prototype. Next slide. Next slide. So, yes. Let me walk through environment sentinels actual measure and dose. I will be quick because there is a lot here. For pH dissolved oxygen, conductivity, and temperature, these four parameters catch 90% of pollution events, industrial discharge, sewage, and chemical spills. We also monitor quality PM 2.5 and PM 10 because air and water pollution often correlate. Factory smoke means factory waste in water. This is where we are special. Our TensorFlow model does just raise alert. They predict. They learn the river normal patterns, detect anomaly before they become disaster. No 4G, no 5G, no problem. Our LoRa network works 5 km without cellular. If one node dies, the mesh network routes around it and we store data locally, sync later. Here's something unique. We detect audio anomaly. Trucks dumping waste at night make specific sounds. Our microphone catch them, GPS track location, motion sensor detection and detects human activities. And it all comes together in beautiful dashboard, real-time maps, historical trends, mobile alerts and in local languages. The key points, everything works offline. Deploy the most remote river stretch, it still works. Next slide. Environment Sentinels is built natively in Google technology. It isn't just a checkbox compilation. We choose this for specific reason. Cloud Run hosts our API, serverless scale to zero while idle. Scale to million during crisis. We pay only for what we use. BigQuery handles our real-time series data, a river generated gigabytes of data monthly. BigQuery analyze it in seconds, not hours. Cloud IoT Core manage our devices security, authentication, framework update, and health monitoring. TensorFlow power our prediction model, LSTM, neural networking, train our historical pollution patterns. And here's what we're proud of. TensorFlow Lite, our model runs on the device of ESP32. I repeat, our model runs on the device on the ESP32. Even without internet, the sensor can detect anomaly locally. Edge AI and not just cloud AI. Firebase syncs our dashboard in real time under 100 milliseconds for tensor to screen. We built a model app in Flutter. One code base runs on Android and iOS. Field workers, officially citizens, everyone gets access to it. And Google Sheet API because sometimes the simplest solution is the best. Village communities can access data in format they know. This is a production grade stack. We are not demoing or a prototype. We are demoing a development ready system. Next slide. So let me show you how it fits together. On the left, as you can see, we have our sensor nodes. Each node is an ESP32 microcontroller with multiple sensors attached. pH dissolved oxygen, TDS for water, PM 2.5 for air, and GPS for location, motion and audio for security. And notice TensorFlow Lite at the edge. I repeat, At the edge, our anomaly detection runs on the device. If a sensor detects something abnormal, it knows immediately even without internet. This nodes community via LoRa, long range radio. No SIM, no cellular bills. A single gateway can receive data from nodes up to 5 kilometers. The gateway has Wi-Fi or 4G to reach the cloud. In Google Cloud, Cloud Runs handles our API, BigQuery stores and analyzes terabytes of historical data. Firebase pushes real-time updates as user access it through multiple channels. Some of them are mobile app for field worker, web dashboard for official, Google Sheet for community access, SIM alerts for emergency. The total latency sensor to your phone screen in under 5 seconds. That's real time enough to save life. Next slide. Let me show you through a real scenario. This is how environment sentinels actually save lives. Step 1, 11 p.m. a factory secretly discharges industrial waste into river. No witnesses. They think no one will know. This is just an example. So step 2, wrong. Our sensor node 500 meters downstream detects pH crash instantly within 30 seconds. The data is transmitted via LoRa to our gateway. Step 3. Our TensorFlow model doesn't just see abnormal pH, it calculates flow rate, predict where the pollution will be in 30 minutes, which village water intake is at risk. Step 4. Simultaneously alert fires, SMS to district pollution control officer. Push notification to village gram panchayat dashboard, show real-time pollution plump movement. Step 5. Response team dispatch. They know exactly where to go, GPS coordinate from our sensors. Step 6. Critical. Downstream village water intake is closed before the pollution reaches. No one drinks the contaminated water. Step 7. Our system logged everything, timestamp, sensor reading, GPS location. This becomes legal evidence. Step 8. The factory faces enforcement action with irrefutable data. Total time from pollution to protection just under 5 minutes. In the old system, they find out in 2 weeks or more than 2 weeks. By then, thousands would be sick or sometimes need to be hospitalized. That's the difference what we make. Next slide. Now, enough of talking and chit chatting. Let me show you what we actually built. So as you can see in top left, this is our sensor node ESP32 microcontroller pH probe. You can see here TDS sensor, dissolved oxygen probe in it, PM 503 air quality sensor, GPS module, all running on a single preboard. Total cost up to 6420. Top right, our LoRa gateway. This receives data from our sensors up to 5 kilometers away and pushes to the cloud. Bottom left, our live dashboard. This is the real data. You can see the time stamp is, as you can see, the timestamp and pH at 7.2 DO at 6.8 milligram per liter, PM 2.5 at 23 microgram meters cube. This river stretch is healthy. Bottom right, mobile alerts. When level crosses threshold, this is what official receive. Location, reading, severity, recommendation, and action. It's done through a notification or alert. Let me give you a concrete number. 2 sensor node deployed and tested. 6 sensor on each node. We tested LoRa range over 5 kilometer line of sight. Ran continuously for 48 hours without failure. I repeat, ran continuously for 48 hours without failure. Our prediction module 87% accuracy of the test data. And here's my offer. I can give you a live demo of the pH or the damaging rivers, but due to our project is not ready or work in progress, we have not yet developed the full project. It is in our college, so as soon as we get the permission will of the college, we will provide you a demo. Next slide. Let me leave you with where we are going. What we built, working to nodes MVP, complete LoRa network cloud backend with real-time dashboard, TensorFlow model running on device, all done, all working. What next? We are polishing our mobile apps, adding local languages support for rural users, and we are in talks with NGOs for a pilot development on a real river. So, question 3 to question 4 this year, solar power integration of true off grid deployment, satellite connectivity for the most remote areas, and sometimes existing. AI that can identify inaccessible species of water signatures. Our vision, 1,000 nodes across Indian major rivers, an open platform that any government, NGO, and community can deploy or access. Here's where you can see everything. GitHub 100% open source MIT license work, fork it, improve it, and deploy it. YouTube or 3 minutes demo video. Watch me deploy the system and detects simulate pollution in the real time. Live dashboard. Yes, it's live now. You can check our sensors as we speak. We built this in a few weeks of intense work and hard work. I like to say it. We build in few weeks of intense hard work. Imagine what we can do without support of Google solution challenges. We are not asking you to believe the concept. We are just showing you a working solution of the crisis that kills 10,000 children per day. Thank you, and happy to introduce to our teams and our project. Sridhar Mane signing off. Thank you.